Today, we're getting under the hood of your food cravings. We're going to look at how a delivery giant like Swiggy is training its AI to build that perfect, personalized menu that seems to know you better than you know yourself.
You know the feeling. You open the app, and there it is, a list of restaurants that feels almost psychic. It just knows you're in the mood for pizza tonight, not salad. So how does it do that? Is it just a lucky guess, or is something way, way smarter going on?
Yeah, it's not magic, not by a long shot. What it is a constant journey of evolution, where engineers are always refining and retraining their AI. We're going to follow along with them as they took a pretty good algorithm and figured out how to make it a great one.
Okay, so before this big upgrade, Swiggy already had a solid system in place. It was a model based on something called a gradient boosted tree, or GBT. It worked, but to really level up, their engineers knew they had to solve three very specific, very tricky problems. So what were these hurdles? First up, the balancing act. How do you weigh finding the perfect food against getting it to you in a good way? Second, the competition problem. Teaching the AI to actually rank things against each other, not just give them a score. And finally, a classic dilemma for all of us, the comfort zone versus adventure. All right, let's break these down one by one. So, challenge number one. Think about it. The AI's main job, its whole purpose, is to find you a restaurant it knows you're going to love. But what happens if that perfect restaurant is clear across town? That could mean a long wait and, a lukewarm meal. And that is not a great experience. And this right here, this lays out the problem perfectly. On one side, you've got your absolute perfect food match. On the other, a speedy, reliable delivery. You can't always max out both. So the engineers needed to teach the algorithm to find that sweet spot, to perform what's called multi-objective optimization, basically to juggle these competing goals.
All right, on to hurdle number two. This one is all about how the AI actually thinks. When you see a list of 10 restaurants, how does the algorithm decide who gets that top spot? Well, the old way of doing things had a pretty big flaw.
Their old model used something called a point-wise method. The best way to think about it is like a teacher grading essays. It gives restaurant A a score of 92 and restaurant B a 91. It knows they're both good, but it doesn't really get that 92 is better than 91 when you're making a ranked list. It's just judging each one all by itself, in a vacuum. So the engineers had a better idea. Let's switch to what's called a pairwise method. And here, the question completely changes. Instead of asking, how good is this restaurant? The AI is now constantly asked, okay, between these two restaurants, which one would the user prefer? By making thousands of these little comparisons, it starts to learn the relative order of things, which is exactly what a ranking is. So, did this new approach actually work? Oh, you bet it did. This new pairwise thinking was 9% more accurate at correctly ordering pairs of restaurants compared to other methods they tried. That's a huge step forward in creating a list that just feels right to you. Okay, let's talk about the last challenge, and honestly, this one might be the most relatable for all of us. We are creatures of habit, right? But we also love to explore new things. Sometimes you just want your usual Tuesday night takeout, but other times you want to find a hidden gem. A really great recommendation engine has to nail both of those moods. The engineers had a great analogy for this. They thought of it as two different skills, generalization and memorization. Generalization, that's the detective. It finds hidden patterns, sees that you like spicy food and suggests a new Thai place you've never tried. Memorization, that's your trusty butler. It simply remembers that you order from Joe's Pizza every Friday night. And here was the problem. Their old model was a pretty good detective, but it was kind of a forgetful butler. And the engineers themselves said it best. The goal wasn't to pick one skill over the other. The real secret was striking that perfect balance. They needed an algorithm that could be a brilliant detective and a super reliable butler. So you've got these three massive, tricky problems. How on earth do you solve them all at once? Well, you don't just tweak the old machine, you build a brand new, smarter one. The team turned to a really powerful model architecture called Wide and Deep, which was designed to do exactly this, balance memorization and generalization. So let's break this down. The deep side of the model, that's our detective, finding all the new suggestions. The wide side is our butler, memorizing all your personal favorites. And then Swiggy added this really clever third piece, a lattice layer, which acts like an expert. It basically injects common sense rules into the whole system. Like, hey, a restaurant this person just ordered from is probably pretty relevant right now. All right, the new model sounds amazing on paper, right? It's a detective, a butler, and an expert all rolled into one. But does it actually work in the real world? Did it really make the recommendations smarter? The engineers put it through some serious testing to find out.
So check this out. This shows how they built it up piece by piece. The basic wide and deep model on its own was already an upgrade over the old system. But then, look what happens when they plug in that smart lattice layer. Boom, another jump in performance. And finally, with a little extra fine-tuning, they got the best results yet. Every single piece made the whole thing smarter.
And here it is, the final showdown. We're putting all the models head-to-head on ranking quality. On the left, you've got the old model. In the middle, that intermediate pairwise version. And then the final wide and deep champion. I mean, the result is crystal clear. This new model isn't just a small tweak, it's a huge leap forward. Okay, so we've seen impressive charts and a lot of technical wins. That's all great for the engineers. But what does this actually mean for you when you're hungry and scrolling through the app? Why should you care?
Well, it means the whole experience just gets better. You get that perfect mix of your go-to spots and exciting new places to try. The recommendations you see are going to make more sense because they're balancing your tastes with the reality of getting food delivered well. It all adds up to a smarter, more reliable, and just more personal menu every single time you open the app.
And the crazy part is, they're not even done. This isn't the end of the story. The team at Swiggy is already dreaming up what's next. Things like building models for specific types of customers and using more real-time signals to figure out what you want in this exact moment.
So the next time you order in, just remember the incredibly complex machine working behind that simple tap of a button. That AI is constantly learning, it's adapting, and it's getting smarter. Which leaves us with one final thought. What do you think it should learn next?